Alright, so this video is going to be about pressure. Pressure is something new for us. We haven't talked about pressure before, but in reality, pressure is something that we have a lot of experience with, and its calculation or its formula or its definition is really something that we can already handle. The pressure is defined as being a force divided by an area. So it's not just about how hard you're pushing, but over what area you are pushing or pulling or whatever. So you can see what the units would have to be. It would be a Newton, which is the unit for force, divided by area, which has the unit of meters squared in the units that we use. That actually has a name. This is also called a Pascal. Pascal was a scientist who did a lot of stuff with pressure, along with a lot of other things, as those scientists usually did. So Pascal or Newton per meter squared are the units that we're going to be using for pressure. But exactly what is pressure? So pressure is that force per unit area, or how hard you're pushing over whatever area you're pushing. So think about this. We have a balloon. Okay, and there's a little, we got a balloon. And then you can poke it with your finger. Yeah, there's a nice finger. Maybe there's a fingernail. Yeah, so you poke it. So there's a force on it. But that force is over quite a large area. So this is the area that we're dealing with when you exert a force on it. So nothing happens. You poke the balloon, it starts to maybe move away from you, or maybe you're holding it in other hands, so nothing really happens. But then you take that same force and you concentrate it with a needle, and what's going to happen? Well, that force is now over a very small area, and the whole thing is going to pop. You're going to pop the balloon. Why? It's not that the force was bigger, but because the pressure was bigger. This area has now gone down. So pressure is important when we're dealing with even very, very small areas, or if we're dealing with very, very large forces. Another example of this is, I don't know if you've ever seen someone's laying on a bed of nails. So we have this long board, and it's got all these nails drilled into it, hammered into it, whatever you want to say. And then, some guy comes over and lays on it. So we got this guy's, there he is, taking a nice nap on a bed of nails. So why is he able to do this? If a needle was able to pop the balloon earlier, then why is a person able to sit on a bed of nails? Well, let's think about this. If we have an entire force of the human being, here's a free body diagram, sitting on one nail, then we have a huge amount of pressure at the top of this nail. Okay, really, really high pressure, because we have the entire weight of a 75 kilogram human being all sitting on this pin nail, or this really, really small area. So we have a really, really high pressure. But what if we spread that force over hundreds of nails? Then we have the same force. Okay, there's our guy. Okay, and he still has a gravitational weight. It's the same, but now only the nails have to account for maybe 100th or 200th of the force that this one nail down here had to. So now no one nail is pushing very, very hard. So we've basically said that we have divvied up the weight amongst the nails. The nails are not pushing very hard, and in fact, they're not even pushing hard enough to break skin. So this guy can lay on a bed of nails. In fact, you could actually come over with a cinder block, put it on his belly, and come down on with a sledgehammer, break the cinder block, and you still wouldn't be able to hurt the guy, assuming that there is enough nails that they can assume all of that weight. So pressure is something that is important, because it's not about force, it's not about area, it's actually both of them. Now, we tend to hear pressure in our everyday language when we're talking about atmospheric pressure. So what does that mean when we have this guy sitting outside, and is he going to feel atmospheric pressure? Maybe, maybe not. But what does that term actually mean? We have a low pressure system, high pressure system, whatever. You hear that all the time in the weather. Well, we have our atmosphere all around us, and all these dots are gas particles and whatever, oxygen, nitrogen, all that kind of stuff. Okay, so this is what we would call a fluid. It's a gas. but all that fluid is exerting a force on the human body. It's all around us. It's surrounding us. Okay? And that fluid is exerting a force. And that force is actually coming from all directions. Let me make that a different color. Okay, so that force is coming from all directions because the atmosphere is all around us. Okay, well, what exactly is atmospheric pressure? It's the pressure that the atmosphere exerts on us, but we don't really feel it because, again, it's kind of coming all around us. So a force from the left is going to be balanced out from a force from the right, and believe it or not, a force from above is actually going to be balanced from a force is from below, so we don't actually feel it. In fact, we have the exact same pressure on the inside of our body. That way it balances out. So what exactly is atmospheric pressure? There's a number associated with it. It does fluctuate on a day-to-day basis. That's actually what drives a lot of the weather. But we take an average value and say that the atmospheric pressure is 101.3 kilopascals. Okay, 101.3 kilopascals. This is a metric unit, so it's 101,300 newtons per meter squared. Remember, that's what a pascal is. It's a newton per meter squared. So that's atmospheric pressure. Now think about what it would be like if the inside of your body did not have the same pressure. What if your pressure inside of your body was higher than the pressure outside of your body? Well, if we know that pressure is force divided by area, we take your body as the same area, we have a higher force on the inside than what we do on the outside. What's going to happen? Well, we know from Newton's laws and all the stuff that we did last year, let's say we have a force down and a force up on the same block, and if this is 20 newtons and this is 10 newtons, obviously the 20 newtons is going to win. So if the force inside of your body is the same or is bigger than the force outside of your body, then all of a sudden you're going to start bloating up. And you're going to explode, basically. And you can think about it the other way around. If the force inside of your body was less than the force outside of your body, the same thing would happen, just in reverse. So pressure is definitely important for us to realize, because we're talking about forces, and if the pressure on one side is different from the pressure on the other side, then there's going to be a net force involved, and that net force will dictate how something moves through a fluid. Okay, don't forget to answer the questions below.